Hey folks, I'm going to connect this generator to my house. This is a Westinghouse iGen 2200. It's rated at 1800 running watts, 2200 starting watts. This unit puts out 120 volts. My house requires 240 volts. So I've got both legs connected through some adapters, and I'll go over all of that later on, show you what those look like. I think to start off with, we'll just start this up and I'll go in the house and turn some stuff on and we'll see how it runs. So the first thing I'll make note of is I'm running the oscilloscope off of power generated by the Westinghouse generator. You'll notice the blinking lights on the front of the generator as it powers up and goes into green when it's supplying power. For the house, the only thing I'm going to do to prep is turn off the double pole breakers, except for the one going to my shop. That's feeding the fan in the background, and I kind of want to show that. Here I'm disconnecting the main power from the grid power, and we just switched over to the generator power itself. I like to point out the two voltage meters in the top right hand corner of the screen. The watts is what we're looking at. You add those together to get the load that goes on the generator itself. I'll label those as L1 and L2 and refer to those throughout the video. Got the sound pressure meter there on the phone, just kind of give you an idea of what we're looking at. But with the heat lamp for the dog turned off, looks like my house pulls around 525 to 30 watts during all times during the day. And just to get things kicked off, we're going to put this space heater on the low setting. That brings us up to about 1120 watts on the L1 side and still 325 on the other side. So well within the capabilities of the 1800 watt generator. I got some overhead lights. That loads up the L2 side of my panel, brings that side up to about 905 watts. Still running around 1112 watts. No problem for this generator. Waveform looks outstanding on this. Pure sine wave all the way at all times. I'm going to try the big load. It's a coffee maker here. It's got a resistive heat in it. It pulls quite a bit of power. So we're starting out at a base level of about 540 watts. And then the generator loads up when the coffee maker heating element kicks in. Looks like we're loaded up to 1620 watts on the L2 leg. Still got 272 on the L1 leg. That's going to put us well over 1800 watts on the generator. You see the yellow light there kind of in the background that changes to red, which indicates an overload condition. And when the generator had enough of that, it shut the power off completely. And so you see the fan stop turning in the background. The generator is not supplying power because I overloaded it with the coffee maker. So they don't give you a whole lot of headroom, over 1800 watts with this unit, but I think it did supply the 1800 watts. We see the overload there, and all we've got to do is reset it. So we're back in condition green. The fan in the background starts back up. The startup power required by my house looks like about 1100 watts. Got fan starting up, probably refrigerator starting up, all the various devices that just pull power all the time, they're all loading up. So we've settled back down to about 560 watts, 570 watts. When I turn my shop lights on, that loads up the L2 side to about 860 watts. Those are LED lights. I thought they were supposed to be very efficient, but they pull quite a bit. I didn't have any problem running LED lights. I didn't have any problems running motors. Those are more resistive lights. Ceiling fans work fine. That's the beauty of a pure sine wave inverter, is all of your inductive loads don't have any problem with them at all. It's just like grid power. My electronics work just fine. The satellite receiver and the televisions all work just fine. I'm just showing a little clip here because YouTube kind of gets butthurt when they think you steal somebody else's content. So the Westinghouse inverter generator puts out 1800 watts at 120 volts. That is 15 amps of current, and that works out well because they give you a 15 amp 120 volt receptacle to plug in your extension cords and whatever you want to plug into it. The problem is my house requires 240 volts, and it has a 4-wire box on the side, and my extension cord that plugs into it has 2 hots, a neutral, and a ground. Well, when you've got the inverter generator, you've got 1 hot, a neutral, and a ground. So what I've got to do is adapt the 120 volt one leg. I've got to split that leg into 2 so that I can connect it to the house. And so I use this extension cord or adapter cord to obviously plug into the inverter generator, and it converts it from 15 amp to 30 amp twist lock. And so I'm halfway there. So what I do then is I connect this adapter cord, which is a 30 amp twist lock with 1 hot leg, a neutral, and a ground. There's the ground. Turns it into a plug with 2 hots, a neutral, and a ground. And so these plug in just like that. All right. And then this one, this twist lock plug plugs into the extension cord that goes into my transfer switch on the side of the house. And so this goes into the inverter generator, and that's how I got power into my house and got it connected. The caveat is that when the utility grid supplies power to your house, you have 2 120 volt legs that are 180 degrees out of phase. When you use an extension cord and an adapter like this, both legs are going to be exactly in phase. And so when you measure from leg to leg on a 240 volt circuit, you're just going to get no voltage, or practically no voltage, even though both legs have 120 volts on them. But that's it. That's all I needed to connect the Westinghouse inverter generator to my house, and it worked pretty well. You're just very limited on exactly what all you can run at the same time in the house. Anyway, that's going to wrap this up. I appreciate you watching. If you liked the video, give me a thumbs up. If you got any comments, drop them below. I appreciate you watching, and I'll catch you on the next one.